Hey everyone, welcome back to the channel. Aaheli here. Today we are diving deep into real analysis from B.Sc Mapa's textbook, specifically chapter 3, which is sets in R. And we will go in detail till the concept of open sets. This video is for the students who want to not just learn but understand the beauty behind each definition. So yeah, grab your notebook and let's begin. Our first topic is intervals. Now, this is a very well-known topic for us because we have learned it in our class 11th and 12th, but let's understand it from our book, which is B.Sc Mapa. What is the definition given there? It is a subset, just S, of a real number, R, is called an interval if for every pair of points A, B belongs to S with A less than B, the whole interval AB is also contained in S. That means now, this is the criteria for intervals, right? Now, what does this mean? This means AB belongs to S, which implies to the interval AB is a subset of S. What does this tell us? This tells us that in an interval, all the values between any two values in the set must also be present, right? Now, what are the types of intervals? There are three types actually. The first is open intervals. Now, we all know what is open intervals. The one within open brackets, right? For example, let's take A and B. What does this mean? This means X which belongs to R where A is less than X and X is less than B. Now, next type is closed interval. What is closed interval with closed brackets like A and B? This means X belongs to R where A is less than or equals to X and X is less than or equals to B. The third type is half open intervals. Half open intervals. This means it got two types actually. First is closed at A and open at B, and open at A and closed at B. How do we write it? First one we write is X belongs to R where A is lesser than or equals to X, X is lesser than B. And here this we write as X belongs to R where A is less than X and X is less than or equals to B. So we completed our interval topic. Now, do you want me to set some examples? If you want, let's take two. For example, 2 and 5. This includes numbers like 2.1, 3, 4.999, but not 2 and 5, 2 or 5, okay? It does not include 2 or 5. If we take another example of closed interval, or let's take half open intervals. Let's take 0 and 1, where 1 is open and 0 is closed. This means it includes 0, but not 1. Okay, now we will come to our next topic, which is neighborhood. This is something new which you will learn in your B.Sc course because intervals we have already learned before. What is neighborhood? By the definition of Mapa, an epsilon neighborhood of a real number x is denoted by n of x epsilon, which is said as x minus epsilon and x plus epsilon. Now what do you get from here? We get is this epsilon is greater than 0 first, and this is an open interval centered at x, where first we are subtracting, then we are adding from x, right? It contains all the points within epsilon distance. This is epsilon distance from x. Now, if you want me to take an example, I'll take one. For example, n of, let's take x to be 3 and epsilon to be 0.5. We will not write it like this, we will write like this, 3 and 0.5. Now, what does this mean? This means first we need to subtract 0.5 from 3, which is 2.5, and then we need to add 0.5 on 3, which is 3.5. So, all numbers between 2.5 and 3.5 form the neighborhood. Is the concept clear? Neighborhood helps us talk about closeness. It talks about closeness and define more advanced concepts like continuity and limits. Okay, we will understand this in the later part of our course. Okay, now let's come to our next topic, which is interior point. The interior point is, let's take the definition from B.Sc Mapa, right? Let A be a subset of R, a point X which belongs to A is called an interior point of A if what? If there exists epsilon which is greater than 0 such that n of x epsilon is a subset of A. Now what did I try to mean here? This means you can find a full neighborhood around X that lies completely inside the set A. Now there is a very important note here to understand. What is the important note? It is every point in an open interval, this is an interior point. So what did I say? Every point in an open interval is an interior point, but points on the edge of a closed interval may not be. Okay. Now let's take example to understand it better. Let us take the first example. Let's take A, which is 1 and 5. Open interval. Any point like 2 or 3.7 is an interior point because we can always find a small interval around it that lies fully in A. For example, it can be 1 and 3. Here it can be 3 and 4. Anything. We are getting full intervals around these numbers, full neighborhood numbers, which lies in this interval, right? So basically what I said is any point like these numbers is an interior point because we can find a small interval around it like these, right? Which lies fully in A. Everything is in A. Now let's take a different example. Let's take closed interval, closed at 1 and open at 5, which is half open interval I have taken right now. Here the point 1, what do you think? Is this an interior point? No, this is not, because any neighborhood like n of 1 epsilon will go below 1, right? Because we need to subtract epsilon from 1, right? So this will go below 1, which lies outside the set. Is it inside the set? What do you think? 1 is at the corner of this interval, right? At the boundary. Then how will a number exist which is lesser than 1, right? On this logic, we can say that in closed interval, we will not have complete neighborhood which lies in the set. Now, if we come to our next topic, which is open set. Now, open set by the definition of Mapa, we say a subset A of R, just a minute. A subset A of R is called an open set, is called an open if every point in A is an interior point of A. What does this mean? This means for every x, now I'll explain what does this mean. It means for every x which belongs to A, there exists epsilon which is greater than 0 such that n of x epsilon is a subset of A. Very important. Like in short, an open set looks like a bubble of points where each point has breathing space around it. Now if I take examples, you'll understand better. Let's take the first example as 2 and 6. This is an open set. Why? Because every point inside this set has a neighborhood within 2 and 6. Am I correct? If I want a detailed explanation, let's see. If we take 1, what is the smaller of 1? So let's take 0.5. And let's take epsilon as 0.5. Okay. Now we subtract 0.5 and here we subtract, add 0.5, so it will be 1.5. So this number includes here, right? So just like that, we can say that 2 and 6 is an open set. Like any interval which is open interval will be an open set. How? Let's take the next example. Let's take minus infinity to 4 or 0 to infinity. Okay, these are also open sets. Now let's take the dangerous example which is not an open set, like 2 and 6, closed interval, right? This cannot be an open set because why? Can you tell me why? Because 2 and 6 are not interior points. Am I correct? Now, if you want a visual idea to understand open set, you can understand like this. In an open set, no point lies on the boundary. This is a boundary, right? No point lies on the boundary. All points are well inside the set. Now, why does this open set concept matter actually? Open sets form the foundation of topology. They are used to define continuity, convergence, and many advanced concepts in analysis. So yeah, that's it for today's lesson. We went through intervals, neighborhoods, interior points, and open sets from the chapter Sets in R. Now, what do you need to do? You need to study this part from SK Mapa. Okay? And if you liked how I broke things down for you, I would really like and appreciate if you give me a thumbs up, subscribe for more content like this, and share this with your study group and study buddies. Thanks for watching, and yes, see you in the next class. Till then, take care. Bye bye. Keep studying.